In this video we're going to go over the notes that you can use for elimination. The goal here is to eliminate one of the variables so that we can find the value of the remaining variable. Just like the first two videos, these techniques are what we use to solve a system of equations. So once again, you'll be given two equations. We have the blue one and the green one here. Step one is to line up the variables from each equation in vertical form. Usually that's standard form, but the x and y don't have to be on the same side. They may already be lined up. Well, I purposely chose one that is not lined up so that we know what to do when that happens. So if you look at the blue and the green, we have the x and the y on the left side on the blue one, and then the x is on the left and the y is on the right in the green equation. So I need to line these up in vertical form, so I need to either have both the x and y are on the left side, or I need to have just the x on the left side with the y on the right. I chose to turn the green one into standard form. It doesn't matter that you put it in standard form though. So by subtracting 2y from both sides, I end up with 3x minus 2y equals -8. And as you can see, when I put the blue one under it, now the x's are lined up and the y's are lined up, which is exactly what I'm looking for. Alright, step two, you'll notice these are the same equations as the ones we have down here with the x's and y's on the left side. So step two, using multiplication, turn the x or y coefficients into opposites. Again, this step may already be done for you. I chose equations where that's not the case. So here we'd like to get either the x's to be opposite or the y coefficients to be opposite. Unfortunately, in this one, multiplication, you can't multiply 3 by a whole number to get to 4, and you can't multiply -2 to get to 3. So in this case, we're going to have to multiply both equations. It's basically looking for a common multiple, kind of like if you were adding fractions. So we can turn the 3 and the 4 into 12s, or we could turn the 2 and the 3 into 6s. Doesn't really matter. Why don't we do these into 6s so I can show you one more thing. So to turn these into 6s, I have to multiply the top by 3. Because that'll make this a -6 here. Now I'm going to multiply the bottom. Instead of multiplying by 2, which would make this a -6, I'm going to multiply by -2 because I want these to be opposites. So this will allow the bottom one to be a 6 and the top one to be a -6, which is what we're looking for. Alright, so the top equation now will become 9x minus 6y equals -24, and the bottom equation will become 8x, because negative times negative, and negative times negative again will be positive 6y equals -10. So remember, when you're distributing a number that has a negative, you have to take into account the signs here. So not only is this acting as a subtraction, it also counts as a negative when you're doing this multiplication. So it is a negative times a negative, and it will be a positive. So now we have the -6 and a 6, and we are good to go on to the next step. So step 3, we're going to add the two equations together vertically. So let's do that. I'm going to copy these and move them down. So let's clone those and move them down here. Okay, so we're going to add these together, and if we did steps 1 and 2 correctly, it should cancel out one of the variables. So we'll see 9x plus 8x is 17x, and then -6 and +6 are going to be 0, so we don't even have to write that. And then -24 plus -10 is -34. Okay, now using division, we can get x by itself here. So if I divide by 17, I find out that x is going to be equal to -2. Let me move this down a bit here. So x equals -2. All right. So moving on. So the next step, I'm going to write x equals -2, so I remember. Step 4, you know the value of one of the variables, which is right here. Plug it into one of the original equations and solve for the remaining variable. So it doesn't matter which one I choose. Sometimes one of them looks easier than the other. In this case, neither of them jump out as being particularly easy, so I'll just use the green one. So we have 3 times -2 minus 2y equals -8. So this becomes -6 minus 2y equals -8. Now I can add 6 to both sides, and I end up with negative, let me move this down a little bit. So I'll have to move all of this up to give myself some extra room here. Oops. Alright, here we go. So I added 6 to both sides, and now I end up with -2y equals -2. And then when I divide by -2, I'm going to get y is equal to 1. Alright, some things are in different spots around here. So we need to put our answer in xy form. So let's do that. I'll just put it down here. So x was -2, if you remember, and then y was 1. So that's what we think our answer is. Step 5 is going to prove it. Check your answer by plugging both x and y values into both equations. Okay, so we have now one of these equations we had changed from the beginning. So why don't we use the original just in case we made a mistake. We'll find out right now. Whoops, because we could have made a mistake way in the beginning and not known it. So I'm going to copy this and bring it to our new page here. Oops, that's not going to work. Alright, let's undo that. Let's paste it lower. Alright, here we go. So, if we plug in -2 here, we're going to end up with -4 times -2 minus 3 times y equals 5. So we get 8 minus 3 is 5, so that worked. And for the green one, we would have 3 times x equals 2 times y minus 8. So -6 equals 2 minus 8. So those both work. So now we know that that's correct. All right, thanks for watching.